Okay, well, welcome back. We are continuing in our many-part, multi-part series on creating RPG games for CPI 111. We left off in the last section by creating an enemy parent and setting up a hit state in that enemy parent that would allow the enemy to be hit by the player swinging the sword and causing the enemy to bounce off in the opposite direction from the player. But that's the enemy parent. Now let's create an enemy that will inherit some of the stuff from that parent and will be something that's actually out in our room. So we're going to create a new object here that is going to be the O enemy skeleton. And we're going to give this O enemy skeleton the enemy run down. Remember, that's the one sprite that we were careful to set a manual collision mask. And we want to use that manually set up collision mask for all sprites that we might swap in and out of this skeleton. So to set that up, we need to come to the collision mask setting and change it from same as sprite to explicitly choose S enemy run down. Okay, we did the same thing with the player, and we had to do the same thing on the platformer. I'm repeating it because I get a lot of emails about students having issues with their player or enemies on the platformer getting stuck in the walls and not moving correctly, and almost without exception, the reason why is that this has not been set up correctly. So make sure you do this, okay? Okay. Then, while we're here, let's make this a child of our enemy parent. And in doing that, you'll see we inherit all these good events without having to write any code from that parent enemy. And now, even though we've inherited all of these, we're actually going to override some of them. And in fact, one of the ones that we want to override is the create event. And we're going to do quite a number of different things in the create event. So the one that we're getting from the parent, set it up the enemy as something that can move. It set it up as something that is able to be hit by other objects and collisions. It set up the image speed, it gave it health, gave it a starting state, and we created an enumeration with only one thing in it, hit. Okay, so we want to use some of this, and some of it we're going to override. So let's go to add event, choose create, and in doing so we've just wiped out the parent's version of that create event, but we want some of it. So in order to grab all the stuff that's in that parent create event, we need to include event inherited, and that will say, hey, take anything that lives on the parent's version of this create event and give it to the child. But even though we now have access to all of that stuff that's on the parent, we're going to override some of it. And one of the things we're going to override is the setup movement object. Remember, on the parent, we did this, but we want to give different values here on this skeleton. We want it to move in a slightly different way. So we're going to say 0.5 for the friction, which you remember is less than what we gave on the parent. I think it was 1 there. And for the bounce, we're going to say 0.5, which may be the same, I can't remember. And for the object, we're going to check for collisions. We'll still do wall. Okay, so we changed a little bit, but not much. Then we're going to create an enumeration here called skeleton, just like we did when we created our player. And in this enumeration, we're going to include all the states that we want to have for our skeleton enemy. And we're going to start with hit, which is the state that we created on the parent, if you remember. Now we're also going to have an idle state. And we're going to have a move state. And ultimately we're going to have an attack state. And if I have time in this lesson, we may have a shoot state. Okay. Might not get to all of these, but we'll get to some of them. Fine. We're going to add another enumeration, enum, enemy dir. This is going to be the enemy's version of the direction enumeration that we included on the player. Now you might ask, why can't we just use dir right, up, left, and down, the one we already created? It's global in scope, so at first glance it seems like we could just use that same one, but we can't. On the player we have an enumeration called dir with right, up, left, and down, and we use that to figure out which sprite to show for our player, but that of course is going to be based on which direction the player is facing. If we want to do something similar for the enemy, we need to create its own enumeration and then refer to that enumeration based on which direction the enemy is facing. Okay, so that's what we're going to do. We'll say right, up, left, and down. Okay, so far so good. We've got that set up. I'm going to come up above here and do something similar to what we did on the player, which is to create a instance variable called direction facing, and we're going to set that to enemy dir.down. Remember, we did the same thing on the player. Now this direction facing is an instance variable that lives on the enemy, on this skeleton. There's a variable with the exact same name, also an instance variable that lives on the player, and those two variables are independent of each other. So we can modify direction facing here on the skeleton and it won't have any impact on the player. They're totally separate. Okay? And what we're doing here is going to ultimately be used to determine which sprite is going to be shown initially when the player when the skeleton appears in the room. Okay. Down below all this, we'll set a starting state. This should look familiar. Equals skeleton.idle. So in our parent, you'll remember, we initialized the starting state to no one, meaning there was no state. It just was sitting there. Now we're going to override that starting state variable that lives on the parent, and we're going to initialize it to skeleton.idle instead of no one. And then we're going to have to create some things to happen inside that idle state. While we're here, we're going to set the state equals to starting state. Same idea as what we did on the parent. We create a starting state that will not change, and we can refer back to this later if we want to set it back to idle. We can just say go back to starting state. But we can update state, and here we're updating it to be whatever is in starting state. And we'll do a little bit of visual stuff. We're going to set the image index equals to 0 just to make sure that we're showing the first frame in whichever animation is going to appear, and we're going to set the image x scale equal to, now this is a little weird, what we want to have happen with this skeleton, I actually don't think we need this as I'm sitting here looking at it. What I was going to have us do is to choose whether we were going to have our enemy facing to the right or face to the left. But because I'm going to set our starting state, our direction facing to down, that's going to result in us showing the sprite for the skeleton that faces down, which doesn't need to care or think about if we are having the X scale be left or right. If I wanted to change this, I guess I can do that. Let's say we're going to make it enemy R right will be the first thing. Then we do need this, because if we want to show the enemy facing to the left, it's going to have to use this X scale. So we'll leave this here and give it a try. Okay. Then we're going to set an alarm here. And this is going to be a different alarm from the one we set before. Before, remember, we set alarm 0. Now we're going to set alarm 1, and we're going to set its duration to the following: random range 0, 1. I'll type this out and then I'll explain what the heck I'm doing. Game get speed. Game speed FPS. Okay, let me explain this a little bit. So what we're doing here, it's unhappy with what I've done. I'm going to need to check my typing. 0, 1 times game get speed. Range 0, 1 times game get speed. Game speed. Oh, no, it looks right to me. Oh, I've got a colon at the end rather than a semicolon. Okay. What in the world are we going to do? So the way this is going to function, the skeleton, is that initially when it appears out in our room, we are setting it into an idle state, and we are going to randomly decide if the skeleton is going to switch into a move state and start moving around or not. And the way we're going to do that is by setting an alarm. Okay. So this alarm is, the way we've set this up is we're going to say, okay, figure out how quickly the room is playing. What this last piece is game get speed, game speed FPS. That's basically equal to 1 second. Okay. This is that's a way of getting 1 second. And then we're going to multiply that by either 0 or 1. So alarm 1 is either going to be set to 0, means it's going to go off right away, or it's going to go off after 1 second. So this is a way of setting alarm 0 to be either equal to 1 or equal to 0. Confusing? Well, why, yes, it is confusing. Okay, this is a way of essentially introducing a pause into the game. All right, and in fact, if I come over here and add an alarm 1, this is our idle alarm. We're not going to do anything with it. We're just setting an alarm. We have to put this description in here so that GameMaker doesn't delete it. And then when we get down to here, we're going to set the alarm for a second. Okay? And that's going to essentially allow us to pause for a second. Okay. Then, let's see. Oh, we got all kinds of things going on in this create event. What else are we going to do? Well, let's create our lookup table here. We've created these 2 enumerations with various states. And just like we did with the player, we can use that information to create a 2-dimensional array that will include all of the sprites that we need to show correctly on our game. And I'm gonna save a little time by copying and pasting here so you can see this. So when we were on the player, if I go back to our player and I look at the create event on the player, we created a 2-dimensional array that we called SPR, and then within that 2-dimensional array we stored references to each of our different sprites for the player, right? And for the location in the 2-dimensional array, we used this enumeration information. So this is like the slot 0, 0 in our two-dimensional array, that's like the upper left-hand corner, or if you think of it like a grid, like a checkerboard. And then we just move through this array and then stored references in each of these locations to the appropriate sprite. So we're going to do the same thing with our skeleton in its create event. And it's mostly straightforward, except you'll see that here, again, I've created a two-dimensional array also called SPR. And the part that's a little confusing is that it seems at first glance like in doing this we're going to override the sprites that are stored in the SPR array, right? Because this is saying in the upper left-hand corner of the SPR array, store a reference to the enemy run right sprite. Well, wait a minute. Didn't we, in the 0, 0 slot of the SPR array, didn't we store the player run right sprite? We did, but we have set up this array as an instance variable, meaning, just like other instance variables, that this sprite array, SPR array, lives here on the skeleton, and the other SPR array lives on the player. So they are two separate arrays, and you can change them each without having any impact on the other. If that's too confusing, you can always rename this something like enemy SPR, but you don't have to. Okay? So I have told GameMaker which sprites to use for the hit and which sprites to use for the idle. As long as I'm here, let's add in the sprites that I need for the move as well. Again, I'm pasting just to save time. Okay. Check each one. Here's hit, here's idle, here's move, right, up, left, and down, and then the appropriate sprites that go with them. And you'll notice these are all the same sprite. It seems kind of silly. But because of the way we are updating which sprite to show, we need to include information for each of these different states, because we're going to use the state in order to allow us to decide which sprite to display. Okay? All right. That's all we need for now for our create event on the skeleton. Close that up. And close that up. Okay. Close this up. Now what? Well, we inherited a step event from our parent enemy as well, and we're going to want to use stuff that's in this. In fact, we can use this code directly as it is, but there are a few other things I want to add as well. So I'm going to override some of this by creating a step event here on the child. Say event inherited, so that I get all that good stuff from the parent. Then I'm going to update the sprite index. Which sprite are we wanting to show? We're going to set it equal to SPR, state, direction, facing. All right. Same thing we did on the player. Is there anything else I'm going to do? Let's create enemy animated. There is some other stuff we're going to do later, but for now we'll just stick with this. Okay, so this is taking all the stuff from the parent, which was this, changing the depth and running the correct user event, and then also changing the sprite. Seems weird. I actually feel like I could do this on the parent, but for now we'll leave it this way. Okay. Okay. What else do we want to do? Well, right now we have a single user event, the hit event, on the parent, but we want to be able to change from that idle hit event, sorry. We want to be able to swap from that hit state into an idle state and into a move state. And in order for any of that to happen, we have to actually have those states. So let's create one. Going to Other, User Events, User Event 1, because we already have User Event 0 on the parent. And remember which one this is. This is going to be our idle state. And what do we want to do? Well, we're going to set the image index equal to 0. So as soon as we come into the state, we want to make sure we're showing the first frame of a sprite. Then we're going to set the image speed equals 0 as well. We want to stop any animation that's playing, at least initially. Then what? Ooh, this is tricky. Okay. Remember a moment ago we set an alarm 1, for either 0 seconds or 1 second. Okay? 0 or 1. It's like yes or no, on or off. Here in this idle state, we're going to make use of that alarm 1 in order to cause our skeleton to switch from the idle state into a move state. Okay? Here's how we can do that. If alarm 1 is less than or equal to 0, okay, which it will be sometimes right away, and it will be other times after a second. So either immediately, we're saying, or after a second, do something. Well, we're going to reset the alarm again. And in resetting the alarm again, we did this, gosh, which assignment did we do this on a long time ago? Maybe all the way back on the fruit? Basically, we want to reset the alarm so that every second or so, whatever we want to occur, which is move into the move state, will. Okay? So here's what we're going to do. Alarm 1 now, we're going to use some different value. Equals random range. Let's give it a little longer period of time now. Now it's going to be between 2 and 4 seconds, and we can do that by saying random range times game get speed game speed FPS. Remember, that was another way of saying a second. So we're going to set our alarm after the first time. We'll set this alarm to be somewhere between 2, 3, and 4 seconds. And we'll switch our state into skeleton.move, which we've not created anything for yet, and we'll set the direction equal to random 360. What? All right. So we're going to, after the first alarm, that's going to go off either immediately or after a second, we're going to reset the alarm for 2, 3, or 4 seconds, or somewhere in between. We're going to switch into the move state, and we're going to set our custom version of direction to be basically any angle, so that potentially our skeleton could move off in any direction, although we're going to make it so that ultimately it can only move off left, right, up, or down. Okay, so we'll modify this. Then, good heavens. Well, I'm gonna leave the then for a moment, and instead focus on what we want to put inside this move state. Well, let's create it. User event. This is user event 2. This is our move, if I can spell, move state. What do we want to do in the move state? Well, in the idle state, we've got the image index set to 0 and the speed equal to 0, so that's pretty idle. It's not going to animate, and we're going to show the first frame of our skeleton sprite, whichever one we set here. Right? Then, now that we're going to move, we need to allow it to animate, so I'm going to say image speed equals 0.34, let's say. And so that it will start to animate slowly, I'm going to create a local variable called x speed. This is our custom version of how quickly we want this thing to move, right? And we're going to use something called length dir underscore x. And let me type this in, and then I'll explain what I'm doing. All right. What does this mean, length dir x? So we've used already in our project, we've used point distance and point direction. Do you remember those? It was a nice way of doing some fancy math to find out the angle between one object and the other object in the room, or the distance between one object and another object. This length dir r is a related built-in function. And what this allows us to do is, let's say we have an object here. In our case, the object we have could be the what? Words will come to me in a minute. We want to know if we were to move off in a given direction at a given speed. Let's say we're moving off this direction, 45 degrees, at a speed of 4. I want to know, what is this value? Okay. What is this value? So that's what this is going to tell us. It's called x speed, but it's really giving us the length of a line when we move at a given speed in a given direction. Okay? All right. And we're going to say if x speed is not equal to 0, it means that we are moving either right or left. Okay. Then I can set the image x scale equal to sine x speed. All right, so this is, we're getting more and more complicated, but basically what we want to do, what this is going to allow us to do is to know whether if we're moving at a given speed in a given direction, are we moving to the left generally, or are we moving to the right generally? And then we'll set our x scale equal to the sine of this value, which is either going to be negative or positive, so it's either going to be 1 or negative 1, which allows us to correctly show the right version of our sprite for the enemy. All right. Then what? Well, remember that what's happening here in our idle state is we are setting this alarm for somewhere between 2 and 4 seconds and moving into the move state. We're going to use this second setting of the alarm to determine when we should slow down and stop moving and switch back into the idle state. So I'm going to say if alarm 1 is less than or equal to 0, that means we want to stop. Okay, so we'll say slow down. Remember this script that just causes us to come to a halt? Okay. Else, we're still in the middle of the alarm, so we want to keep moving. So we need to, while the alarm is still going, we're going to first figure out which direction we're supposed to go. So we can use get direction facing, that custom function that we looked at a long time ago. We pass it which direction it is that we are moving, and we speed up in that whatever direction it is we're moving. Okay. And this is just saying from what speed up to what speed. are we moving. Okay. Remember that none of that actually moves anything. It's just telling us within this given moment of time, are we speeding up or slowing down? Or do we want the thing to speed up or slow down? And then to actually move it, we have to say move object true. We want this thing to bounce. Alright, and then finally, in this long and pretty complicated lesson, we want to react to the cessation of movement. So if our custom speed variable reaches 0, which is possible inside this slowdown script, then we're going to set our alarm again, and I'm going to save some typing here. Go back into my idle state, and grab all this stuff, come back into my move state, paste it in, but change the values. I'm going to set this alarm for between 1 and 3 seconds. What that's going to do is determine how many seconds we want to elapse before our enemy might start moving again. Okay, and I'm going to set the state equal to skeleton.idle, like so. Right? So again, the idea is, oops, I've got one too many of these little fellers here. If here in the move state we'll move, right? Make sure we show the right version of the sprite. We'll check our alarm, and if our alarm has reached 0, we're going to slow down to a stop. If it hasn't reached 0, we're going to speed up. I'm not 100% sure we need this line, but I'm going to leave it in here for now. We might be doing this elsewhere. Then we'll actually move the object. Here, if our custom version of speed reaches 0, it means the player has stopped. We'll reset the alarm for between 1 and 3 seconds and move out of the move state into the idle state. And if you look back in the idle state, that will stop the animation from playing, move us back to the first image, and then check this alarm that we just set. And if the alarm's gone off, we reset the alarm and we start moving. So this is just switching back and forth automatically between the idle state and the move state. Now, I know this is a long lesson, but before we leave, let's see how many mistakes we've made. So I'm coming into my room, selecting the enemy layer, grabbing the enemy skeleton object and dropping it in the middle. And let's see if we get some errors. Okay, yep, doesn't like one thing. It says I have a malformed statement at line 5, right here. Aha, do you see what it is? I've got this semicolon here, which I don't need. Save it, try it again. Again, when you find errors, GameMaker is very good about telling you what the problem is, and you can use that to figure it out. So here's my enemy. Oh, he's got something kind of weird going on. He's doing that kind of crazy wiggle waggle back and forth. So we'll need to modify that so that he doesn't do that, and we'll do that in a second. All right, but for now, this isn't too bad. We'll stop him right here, and then in the next lesson we'll fix that, and we'll add in an attack state for our enemy. And I think I can hit him, right? Yeah, I can hit him until he runs out of health. Alright, so we'll take care of that little bit of funkiness in the next lesson.